So let's start. Automated extractions and visualization of data. I would like to point out that this is not to be seen as a, let's say, formal training in these tools. It is to be seen as we try to put together some inspiration on how to use the IBA systems. So hopefully we send some new input out to you that you could try in your own IBA systems, or see examples of how you could do with the IBA systems that you would like to try in your own system on the office or in the factory where you belong, let's say, where you represent. So if you're interested in trainings in these tools, we are happy to help you, of course, with that part. First of all, and most important, again, thank you so much for the interest you show by being here today. We are representing, I think, 7 different countries today as well, and these 8 companies are participating. So we really appreciate that you take your time to be here with us. So thanks a lot for joining us. Really means a lot. Thanks. The agenda for the day will be some background and introduction to the system, and also I will give a little bit extra light on the ibaDatCoordinator, because ibaDatCoordinator will be the central part of this webinar. We will have a look into 2 cases. One post case or history case where we look back on data and perform something called a one-time job inside ibaDatCoordinator to extract data from that historical data into a database as a key process parameter or a key process indicator. For, let's say, you would like to extract the average roll force in the head of the strip for a certain stand during the 31st meters, and you would like to do that for 3,500 strips, let's say, to follow up how the average value trends over time. Then I will show you one way to do it today. The other case is the real-time or future. A future is not I realize now it's not, we don't mean to predict something into the future. I just mean that we can handle situations that happens now in real time and that will happen in the future. So we use something called event jobs in the dat-coordinator that is somehow related to the IBA PDA event stores. I will show you that today. So two cases, one history and one now and future. And then we sum it all up with some keywords and notes, what we have done today, and we have a discussion. So, some background and introduction. We start with this one-pager to show in a simple way the IBA system. In the very south, we have different signal sources. Could be analog digital signals, bus modules, PLCs, video signals, or data coming from our manufacturing execution system. We use different interfaces and tools to communicate with all these different signal sources and put all data into IBA PDA, which means process data acquisition. Inside here, as you probably already know, we set up and define how the measurement itself are carried out, the sampling frequency, and how fast we would like to store data, and so on. IBA PDA saves or stores data in 2 main formats. One is called the dat-files, and the other one is called ibaHD-Server. I will talk a little bit more about them later on because they are part of today's topic. Those data sources, dat-files and ibaHD-Server, can be read by the IBA analyzer post-processor, the IBA post-processor called ibaAnalyzer, which we covered on last webinar. And as you know, in the IBA Analyzer, we can do our trend analysis or analysis on real-time data via the ibaHD-Server then, and alarms, and we can do reports, and we can do aggregated calculations to put in a database and later on visualized in ibaDaVIS, let's say. We'll show you that today. There is also another stream of data possible in the IBA system, which is more of a real-time stream of data from the processes. You put the IBA PDA as a layer on top of your processes to collect the data you need, and then you publish them northbound, let's say, via some stream interface or like OPC UA or anything else for other systems to use, like a manufacturing execution system that needs actual processing times of a product or stuff like that. So you can think about process development and optimization maybe in this width direction of the slide, and an integration direction will move from south to north in this slide, where you grab data from the processes and then maybe you process them a little bit in the PDA and then you publish them immediately for other systems. Okay. And in terms of a webinar map, let's say, the first webinar we had 2 weeks ago, we covered the IBA Analyzer part, and now we're here, the red line. Then we have 2 more webinars in mind, partially planned, but not planned to date, let's say. We will come back to those later on with the specific invitation and so on. So now I would like to introduce you to ibaDatCoordinator and how the ibaDatCoordinator can be used in a few ways, at least. I used to think about ibaDatCoordinator as a planner and an engine. Oops, there's a Swedish word. Then you sorry, you learned that and means och in Swedish, or vice versa. Och means and. Planner and engine. And planner because of you can put up a sequence of different jobs. First you do this job, and then based on the result of this job you would like to do another job, and then An engine stands, I mean like it's the engine that performs this automatically for you. So you don't have to do the work yourself. It's like an engine. But you have to tell the engine what to do. And then the planner part comes into equation. One level of use of the ibaDatCoordinator is something called the PDA level. You can have a PDA, you can have an ibaDatCoordinator installed on the same level as the PDA, let's say, to carry out some specific jobs. I will show you. The next level would be the user level, where the, let's say, process development engineer uses the ibaDatCoordinator to do some long-term trends on aggregated values just because he or she needs it for the tasks of today, let's say. It might be that no one else are interested in those values, but you can use it for your own work, and then you can use ibaDatCoordinator on your own local computer to do those aggregates for you. And then there is a big use, of course, of this system on the system level, I call it, when the ibaDatCoordinator produces data, maybe to databases for the whole company. Keep tracks of key process indicators, or key process parameters, as I prefer to call them. You follow some important process parameter that you have learned about that you need to keep track of, because it's related heavily to the quality of your product and so on. And the different jobs inside ibaDatCoordinator, if you go back to the bottom part, the PDA level, normally you can think about job types as scheduled and triggered jobs. It means that you can put in a schedule for jobs being done. I will show you later on what these jobs can contain. You can also use triggered function as soon as a dat file is produced, will trigger a new job start inside the ibaDatCoordinator. Normally you can move a file from the local storage where the PDA is up to some office net to the colleagues so they can use the data file and so on. Sorry, I went too fast. On this, like this laser up here on the user level, normally one-time jobs are done. You do something one time, maybe you take this average temperature in a furnace zone and you perform it for very many times, many occurrences, but it's enough to do it one time because then you have all the data to work on, and then one-time jobs are used. And then on the system level, normally we can think about event jobs or trigger jobs. I will show you today this event job and the one-time job. And different tasks that you can dedicate to the different jobs. I mean, a job contains of different tasks. And these are some examples of the tasks. One task could be to create a report automatically based on some data that you define, and you define also the calculations behind how you would like to perform the report and everything with the graphic, how the graphics should look in the report and so on. Extraction tasks, it means you can extract data to databases or to files, let's say, as a couple of examples. Copy task, it means you can have ibaDatCoordinator to copy a file from one folder into another one. Conditional task, it is a kind of a task that will, let's say, pre-process. Actually, you can use this in many different ways. This is just some examples. You can use it to pre-process a little bit data for you. This is an example. Imagine that you have rolled some 70 strips on a Saturday night or during the Saturday. And then you would like ibaDatCoordinator to loop through all the data in those 75 strips you have rolled, to check for if the roll force in some of the 7 stands have been greater than, let's say, 2,700 tons. If that had happened in some of the stands, then you would like ibaDatCoordinator to move that dat file where this have happened into a new folder, something like, please check this up, strange roll force, I don't know. Otherwise, you can just put it in the normal folder to handle as a non-variant, so you don't have to check it up immediately. So that's a kind of condition you can have ibaDatCoordinator conditional task for. And then the sequence comes if you have the map, the folder where you have put these cases where the high roll forces were. On those, you can then perform an extraction of that roll force into a database or a report or an email or whatever. So that's where the planner comes into the equation. Do it in the correct sequence. Okay, and then we have a cleanup task. Cleanup means, as it sounds, it keeps tracks of disk quotas and stuff like that, so we do not overfill disks. Then that coordinator can keep track of that. And then splitter task. This split dat, this I will show today. It splits one dat file into many parts. And why would you like to do that? Yeah, because in the example of today, I would like to extract data based on a certain condition that is fulfilled, and I would like to have one new row in the database for each time that happens. Then I split a dat file today, you will see, into many parts, and then later on, when the splitter task is done, I will extract some key process data from those splitted dat files into a database. but it will be clear in a minute. I will show you. And then HD import. You can use the ibaDatCoordinator to, if you do not write the data here directly to HD-Server for some reason, maybe the connection goes down or you don't do it, then you can use the dat-files to fill the gaps, let's say, in the HD-Server. As soon as there is a new dat-file ready, please write it into the HD-Server. Okay. Today we will focus on these two user cases by showing you two examples that I have prepared for you. Just a few words about the difference between HD-Server and dat-files, because I will use them. I will use dat-files in the first example, and then I will use HD-Server in the second example. Imagine we have a production of a hot strip mill or a bakery or some oil, I don't know, something with some products, 6 products in this example, and you have the time running from the left to the right. Then the time-related dat-files, we call them, they are triggered, let's say, every 10 minutes or every 6 minutes or every 10 hours or 10 seconds or whatever you prefer, the length of the dat-file, we trigger a new one. So we start here. We take 10 minutes long file. We store that one to disk and immediately start to write the next one. So we don't care about the products over here when they are produced. It's a continuously measurement over time with the same time, with the same length of the time. Okay. Then we have the product related or the triggered one. No, it could be some other trigger also, but this one is triggered by the product. Could be some happening in the, not happening, could be some occasion, some process state that triggers the dat file also. But in this case, you see the start trigger here correlates to the starting point of the product number 1, and the end trigger, the stop trigger, is here. It means that this dat file that we store here only contains data for product number 1. And then we do not save any data here. Here is a gap. And then product 2 comes, we start a new writing of that file, and we store it to disk when product number 2 is finished, and so on. And in the HD-Server case, we store, we put every new available measurement point in a big, it's like a big bucket, let's say, but a very well structured and well ordered indexed bucket. So you put measurement data in the same place. It's like an open dat file, like this one, without an end, let's say. It just goes on forever. And we put also in that something we call events of different types. You can specify the events. Here you see the product start and product end events, the red ones. Maybe you have some extraction events where you would like to extract data, as I will show you today. Or you have some downtime, maybe it's a role change or some problem in the line, let's say. And then it's in the HD-Server case, it's up to you as a user to define. Well, it's like when you query a database, you will define from where in time to where in time you would like to collect data, and also you can enable some signal conditions in that time window. Maybe you ask the HD-Server to show for you every time the roll force in stand 3 has been greater than 2,400 tons during more than 5 seconds the last 3 months, let's say, and then HD-Server will return for you. Here you are, my friend, 46 times this has happened, and here is the data for them together with all the other process data. Okay, that's the main difference. And now, soon we will jump into, this is not a PowerPoint presentation. This is a PowerPoint presentation, but soon we will jump into the dat-coordinator. But I give you some background to case number 1 first. Imagine time-related dat files. Imagine that we are here now, And we, as a process development engineers, we find something very interesting that we would like to track back in time. We find a key process parameter as an aggregated form. Maybe it's an average of something that indicates a very interesting finding that we have done. Now we have a lot of cases in the history we would like to perform this calculation of. So this is what we will do today. We will use the dat-files. We will automatically read it in the background into ibaAnalyzer, perform some average calculation, and we will put it in a database. And I will show you. It's the dat-coordinator that will perform this. Yeah, some examples of use, but I think you get the point. The big purpose is to find an aggregate that describes something and then extract it from the history data. Here's an example, just a screenshot from the analyzer, that the data we will use today. The blue line comes from the process, and the red one is an indicator or a condition for when we would like to extract data. Yeah, and I put it here, the recipe, let's say, being used by the dat-coordinator is an analysis file that is executed inside ibaAnalyzer for each and every case of this happening. It happens in the background. Now we will move to dat-coordinator into the one-time jobs. And as you see here, I have created something called split dat-file on event. And event, maybe a little bit misleading word, but it's event that is defined upon dat-files, not the HD event. That will be the next part. So you just point them out where you have your dat-files. Where are your dat-files? And then we go into the split definition, because now I would like to split the original dat-files into many parts that contains only information about, you remember the red signal in the last slide, the occasions from where I would like to extract data. You point out here in an analysis file that contains the expression for when this split is about to happen. And you see here I have created something called a trigger extract, and I would like ibaDatCoordinator to look for when this signal is true. I would like to do the split from the rising edge of this signal to the falling edge. And I would like to have all the splitted dat-files in a new directory called splitter. And then there's a lot of other settings, but just to show you how it works. We were not fast enough, but here you see splitter task started. You can see the timestamp here. Splitter task successfully completed. And we have also the stopped processing. Okay. Then the next, because now we have all the splitted dat-files. Then we would like to perform an extraction routine on those splitted files. So it means that we point out again where are the dat-files. Now it's the splitter map, the splitter folder. I say map because it's map in Swedish folder. Sorry, it's the splitter folder we are going to look in. And in each and every case here, we will perform an extraction routine that is defined in an analysis file. And I can show you how it looks. here. You know, you put your database connection over here, but that is already done. Then here, computed columns. I do some calculations in here. So these three values together with some other values will be extracted into the database. Now go back to the dat-Coordinator and we will perform this extraction. Hopefully, we start this job. We go to the logging and you see now it's looped through. It's very fast, we're not able to see it, but we go back to the database that I just showed you. Here again, the database, and we have a look in this table now. See now, it is 61 rows in here containing average, standard deviation, and maximum values. But here you can perform any calculation that you can imagine with the tools of ibaAnalyzer and the mathematical and statistical and trigonometric functions that you can, all of them can be used to create these values. I just show you an average value now, together with the standard deviation and maximum value as an example. Okay. So what have we done? If we go to the ibaAnalyzer part, this was the start case. Here's the signal that we started to work on, the dot file stitched or appended. And the red one was the identification for when we would like to extract data. So if you look here, for each and every red occurrence here, we would like to extract data. Now I will add all the splitted dot files, and you remember I said when we looked into the database we had 61 occurrences, and here 60 is the highest value. So 0 to 60 means 61. So we open them and we append them on multi-select. And we have a look at this value. Now I read in the same value. I will put some more thickness on this line. It's easier for you to see. So now the green, oh, we zoom in a little bit, sorry. We zoom in here and have a look. The green line now, this is split file number 1, number 2, number 3, number 4, number 5, and so on. And the splitted files contains, now you can see, only data. I put it this way. The splitted files is like an X mark valid of the blue line during the condition that the red one has to be true. So as you can see, the splitted file only contains data from the blue line when the red is true. So on top of this now, we will read back data from the database. You remember the average, standard deviation, and the maximum value. We put them here as a signal again. Okay. And we take the average value from the database and we put it on the same scale, and we do a little thicker line, and I normally we put them as points when we read in aggregates. You see, this means that this dot here represents the average value of the green line during each of the red occasions. So if you zoom out all and you just look at this. This is a way to keep track of your key process parameter for the history, let's say. And this can be done now. I did it for 60 occasions. But this, of course, can be done for thousands of strips. And there's another one. See, that's how it works. And the data from this extraction I have put in a database over here called event jobs, just for this webinar. So we put here now data for every time this event happens. We fire a calculation and put, remember these 5 process KPIs I showed you inside the IBA analyzer. They are here, containing all the data. And on this database now, I use this database as a data source for the ibaDaVIS. And it looks like this. So here, ibaDaVIS reads and auto-refreshes now every 10 seconds and reads in the latest data here. So the latest data I have available in the database, it comes from today at 10:40 Swedish time. And time now is 10:41, so it's 1 minute ago. But it reads automatically from the data. So it always about when the, oh, there is it, a new one, 10:41. The data is here and all these graphs are updated with the latest data in the database. So that's how it works. And now I would like to go back to the dat-coordinator because I promised you also a mail routine. Send email up on these events. And you see this one is disabled because otherwise the mailbox would be it's so many events, so it would be a lot of emails. So we go in and we take execute always. And then I have to just quickly restart this ibaDatCoordinator. And again, we wait for we wait for an event here. I will take a sip of water. And now I think I started the dat-coordinator when this event was already ongoing. Therefore, this one will not be included. So we will react, not we, ibaDatCoordinator will react upon the next event that fires. So we have to wait a few seconds before the next event fires here. There's a new event. And when this event now ends, maybe here, and we can keep track of the dat-coordinator. Yeah, you see here. Yeah, here we are. You see here, one extraction is made, extract routine, and one report routine is also made with success. You see the blue little tick mark. No, not yeah, but the mark here, the blue one means we are successful in the extraction and also in the report function. And in the report function, there is a email function activated. And what this does, it sends an email and it also attaches one report of what has happened during this event. I will show you. I will just stop this mail send here. And then we have a look somewhere there. Sorry, I put it on the wrong screen. I'm very sorry. This I should have prepared. Anyhow, now we have 3 report emails. So sorry, I take this again. We have now 3 emails being sent to us by an event-based, let's say, engine inside the dat-coordinator. And we can open some of them. And we can look at the PDF file, how it looks. This is a report. I just made it. Here you can put in how much energy you would like to do with graphics and stuff. But just to show the inspiration, just to show how it works. Between the dates here, you see the timestamps. The furnace temperature average was 157 degrees. The average. And the maximum temperature during this the elapsed time for the defined process date was at the marker Tmax 165 degrees. You can see here. If you follow that one to the left, it seems to be correct. It happened also 10:43:05. Okay, back to the PowerPoint for a few words. I'm a little bit delayed, but I think we will just a couple of minutes and then we can have some discussion. And sorry again, a typo. Notes and keywords, it should say. We have now, today we have used, as you have seen, ibaAnalyzer is a central part in more or less a lot of parts inside the IBA systems. Now today it executed the extractions that was, let's say, driven or by the ibaDatCoordinator. So it happens in the background, but it's the ibaAnalyzer that calculates and performs the extractions. We use the data extraction tool inside ibaAnalyzer to land all the data in the database. Used, of course, ibaDatCoordinator was a central point, and we had two different kind of jobs that we had a look on today. Event jobs was the first one, and we also used the one-time jobs to take care of the, the process development engineer investigating the history of some interested KPI or process parameter. We used PDO files. What is that? That is analyzer analysis files. It's called PDO files. We used the ibaHD-Server and we used the dat-files during the two cases of today. Data storage we talked about, different kind of data stores, where one of them is the ibaPDA event store, and the ibaPDA event store holds the HD events that you can define and that we defined inside the ibaPDA to have the dat-coordinator to look on to automatically fire on those events. Trigger, yeah, you know what that is. We had something to trigger a start of a DAT file or a trigger extraction work. ibaDaVIS I just showed very quickly. It auto-refreshed itself, read in the latest available data from a process data source, which actually was the database today. It was an SQL database. We put data in, and the daVIS automatically updated with the latest data. We worked in both history and history post. I put it together, and we worked in real time. And real time means also every occasion in the future that will happen that we can define. So again, webinar map. We have now done two webinars, ibaAnalyzer and ibaDatCoordinator, and we have the two webinar 3 and 4. They are planned content-wise, but not to date. So we are working on that, and we'll come back after the summer with more information. Okay. Once again, thank you so much for participating. I should also say, if you're interested in our trainings, if you wonder a little bit and would like to learn how we did all this today, or if something was unclear or so you would like to learn more, please do not hesitate to just visit our homepage for some information, and we are happy to help you with trainings and stuff like that, also online nowadays. All right, then I wish you all a nice day, and please stay healthy, stay safe, and then we talk later on.